Hi all, it's Juha from Ellie. Today we're going to talk about data mesh and how data modeling relates to that. So in effect, we're going to go through a couple of basic principles of what data mesh is all about, the brand new thing, the shiny new thing, and we will be looking how data modeling, a kind of old and trusted but excellent method, is going to fit into this new paradigm, new way of doing things. Couple of words about me. I'm the CPO of Ellie Technologies, Juha Korpela. I've been doing data stuff for, 12 years now. And my day job, of course, here at Ellie is to deal with Ellie's product development and product vision. But I also do all sorts of methodological things and best practices and help our clients and partners to deliver value with our product. The kind of background idea behind Ellie, behind me, and behind what we're going to be talking today about is that there's kind of weird mismatch between kind of the usual sort of development work that is being done and then the data development work. And the data development work is such that we really tend to jump into technical implementation almost immediately. So we're super interested in technical tools, and we do ETL and we do ELT and we do cloud things and all sorts of stuff. But there's something missing before that we're not very good at paying attention to. In any kind of normal design and development process, you'd start with a sort of preliminary steps that would involve you figuring out what the product is going to be about. So for what need am I building this? Figuring out who the users and stakeholders are going to be and involving them and so on and so forth. In data world, this is often skipped because you just want to get engineering. We're going to be looking at this kind of problem from a couple of angles here. The first angle is that of data mesh. So I'll talk a bit about what data mesh as a paradigm is, how it kind of fits this sort of design thinking and bringing things closer to the actual business. And we will figure out a couple of kind of pros and cons of this approach. It has some challenges that we need to be able to overcome. Then we'll jump into looking at data modeling. So how does data modeling as a methodology, as an approach, work to make data mesh kind of more viable and more easily achievable? How Ellie is helping you with that as a tool. And then we will be kind of mapping this kind of data mesh principle set into data modeling and figuring out different levels of data modeling connected to different parts of the data mesh paradigm and seeing what comes out of that. So let's get started with the kind of absolute basics of data mesh. Data mesh is a paradigm, a framework of data architecture, really, invented by Zhamak Dehghani, who has written an excellent book on the topic. And this is in its core a decentralized, domain-oriented framework where we are kind of focusing all the data work around business domains instead of like centralized IT or anything. And we tend to have the capabilities and the knowledge and the competencies around data split into these domain-specific teams. And the domain-specific teams are responsible for the data. They own the data. And these teams operate with the actual business experts in that domain. So we're decentralizing the data capabilities. We're making sure that the ownership of data and the implementation of these technical things these are very close to each other. And we try to manage the analytical and operational data in the same organization, same kind of a team, so that there's less gap between the analytical uses of that data and then the place where the data is actually being generated in. And all of this is done in domain-oriented way. So we want the team to understand what the context of that data is, where is it being used, where it comes from, what the basic quality is, what the systems are, what the experts involved are. And then these domain-oriented teams are sharing that data via data products. The data product is a super important concept here. The data product is the way that the domain shares data outside it. This network of domains and data products which link these domains together, this is of course then the mesh. And The nature of this is of course decentralized, but there is a centralized platform capability then which provides these domain teams with tools and capabilities to actually build and maintain their data products. In effect, this is what it looks like. We have here a business domain that might be sales or marketing, or it could be something more specific, like if we were running an airline, it might be ticket sales, or it might be pilot management or ground service or something like that. The domain itself kind of deals with its own things internally. It can be highly optimized internally to have its own tools and processes and everything. It can do whatever it needs to do to deal with that business domain. So this contains all the actual systems in which this ticket sales, for example, happens, and it contains all the necessary capabilities to run that and all the necessary capabilities to build these data products. And the data products act as interfaces between our domain here and all the other domains in the mesh. The data products themselves then operate on a shared data mesh platform underlying all of this. The platform itself doesn't do much, but it provides the capabilities for these domains to actually serve these data products. And the rules and policies on how these data products are used, how these domains operate, those are defined at the platform level. So everyone's playing by the same book, but they are doing their own things inside their own domains. That's the basic idea of data mesh. Of course, there's much more to it, but I'm really simplifying it here for the purposes of this presentation. There are 4 principles that govern how data mesh operates. These are directly from Degani's book. The first one is domain-oriented ownership of data. So the domain owns all the data. There's no external IT department or anything that takes care of it. Domain needs to own it. So the business domain takes responsibility of having that data for itself and also the responsibility of serving it outside. And the serving the data outside is data as a product principle. So we want to have these kind of well-defined sets of data that we take care of in the domain, that we provide as a service, kind of as a product to other domains to utilize our data for their needs. So we ensure that, okay, we have a set of data here. It contains tickets and sales and customers and so on and so forth. Here, you can take it, you can use it. These are the rules and the policies. This is the content described in this way. This is the technical approach that you have. We are packaging that into a kind of data product and offering that to the rest of the organization. So this is product thinking really applied to kind of analytical data. Another thing is that we have these centralized capabilities, the data platform, the mesh platform underneath all these domains. And the idea behind that is that this platform has to be kind of self-serve capability. So all these different tools, data storages, analytical tools and methods that are utilized across these domains, across the mesh in different kinds of data products, all of them are served from the central data platform, the data mesh platform, but they have to be in a self-serve mode so that the domain teams can come up and pick the tools they need and utilize them in their own data products. The last principle is called federated computational governance, and the idea behind this is that there's a set of kind of standard rules and policies and ways of working and quality rules and principles on how data can be served and so on, which are agreed on a central layer behind these kind of individual domains, so that the domain experts, the data owners in those domains, they communicate with each other and they set the common rules which are then enforced by the data mesh platform. So again, the capability of enforcing these rules comes from a centralized platform, but the rules are agreed between all the different domains, so they are not kind of coming in from outside. These are the 4 principles of data mesh. Now, there are a couple of things we have to consider here. First of all, a good thing about the mesh approach is that the domain orientation of these teams ensures that there's intimate knowledge of what the business actually does and what the data contains and what the data means within that team. So obviously, if you have your ticket sales domain, that means that the data engineers and everyone working in that domain, they really know what the ticket sales looks like, how it behaves, what the data is. The challenge with this is that now the domain knowledge is centralized into this domain team, but the other teams, the other domains also need to utilize that data. So how can we share that knowledge of what the ticket sales data looks like, how it behaves to everyone else? This is a challenge we have to take into account. Another thing is that having that common mesh platform, of course, ensures that the data products are kind of technically interoperable because they're all using the same tools and same principles and policies, and they are easily available and they are kind of technically consistent. But can we get somehow an understanding of what the data is about shared between the domains? The central mesh platform doesn't care about the data content. We have to be able to somehow communicate that across these domain boundaries. The third issue is that having this kind of federated governance thing, it does ensure that we kind of follow a certain set of rules, that we understand what others are doing in terms of rules and policies and so on. But there's nothing governing the language that we use to describe our data. So the challenge here is that we need to be somehow able to govern or at least document the language that might be highly domain specific that still must be used when we are sharing data between different domains. So these are some challenges about the data mesh approach that we think can be approached by utilizing data modeling. So in effect, it all comes down to content and context. We want to make data products that are served out of the domain, that are business friendly, that are easy to utilize to people outside our own domain. It means that we need to be able to share between different domains. We can provide all sorts of technical interfaces, that's perfectly fine, but the content in a data product is the same always, regardless of the kind of technical interface that you take to approach that data. The content is what the data consumers really care about. So technical tools might be whatever. You have a set of tools provided by the platform, but you have to figure out what the content is, because that's what people care, and you need to be able to communicate that content, not just the set of technical tools used to access that content. The key about kind of business-friendly data products and useful and valuable data products is that only with understanding of the context of that data content is the data actually valuable. So what is this data used for? If we have data about customers, what does that actually entail? The problem here is that we don't often speak the same language, so we need to be able to describe this context. This data is about customers who are the customers who actually buy our products via visiting our web store and doing stuff there, and so on and so forth. This is context about the actual data content we have. So to be able to design these kinds of data products, we have to design them content first, and we have to be able to communicate that content and the context of that data, what the data is really about. In effect, if we want to align data mesh and the data products we're building with the actual real business goals, because let's be honest here, just building a data mesh doesn't actually create any value at all. The value is created when data is being consumed and utilized. We have to start with the business goals which are not defined in technical terms. There are no business goals about number of API interfaces being built or something like that. It's always in terms of sales and customers, market share, and so on and so forth. So what sort of data products do we need to make available in order for the organization as a whole and domains as kind of specific entities of that organization to be able to move towards these goals and actually produce value? That's the starting point for data product design in the mesh. So we start with the idea, here's what we have to achieve. Then we start thinking, okay, what do we need to know about? What information do we need to have that would help us achieve that goal? And that is the data product design part. So we're figuring out what content the data product must have in order for us to reach a goal. And then once we've figured that out, we can move to the technical implementation of how to actually build a data product that contains that important stuff. Then the data product is being utilized, and that hopefully moves us towards our business goals. This is how you design data products that actually produce value. How to do that? You do that with the help of data modeling. We want to understand the content, we want to understand the context in which these data entities and elements appear. Data modeling is a way to do that. Data modeling is an attempt to understand the information content we have about the business. There's a quote by Alex Sharp there, and it's an excellent quote. The data model is a description of a business in terms of things it needs to know about. So we are in effect describing the business need. We are not describing at the initial stages of data modeling, we're not describing databases or anything like that. We are figuring out what are we interested in. Customers, products, services. And then we try to clarify the terminology that we use. What do we mean by customers? What sorts of customers we're interested in? We need to share the meaning behind these words. We need to be able to share that between different domains. Now, a good data model always kind of gives the data some context, that this is how customer data relates to other things here. And this is the sort of metadata that you cannot catch by simply implementing kind of technical solutions like purely technical data cataloging or something like that that simply register the technical elements of your data products. You need to have this contextual understanding of the data. What Ellie does is Ellie helps you figure that out. We use Ellie to collaborate with other people. You have your business experts, you have your technical experts. We use Ellie to collaborate with them, to cooperate them to design these basic principles. We need data about products, recipes, production lines. Good, let's draw that. What do we mean by a product? This is made very fast, very easy with Ellie. You don't have to be a data modeling expert. You don't have to be a data architect or an engineer to figure this out. This is simply about talking about the business. So collaboration, fast and easy access to everyone, and the tool itself is cloud-based, so there's no limitation to it. Basically, you can get everyone involved. That's super important for us at Ellie. The idea is that as you create these designs for your data products, you're also creating a repository of knowledge. And this is a repository of business knowledge about what things your business is actually interested in. What do you have data about? How all of these relate to each other? You do have the individual diagrams describing specific data products, but all of them link together. And everything is interconnected via the kind of combined knowledge repository created by the business glossary. So the business glossary contains your understanding of what a customer is, what a product is, what do we mean by a sales order, and every single diagram, every single model, every single design that you create links back to those. So this gives you the ability to show how your organization is actually interconnected across domains via all these different data products. Here's an example. So imagine now that we are in flight business, we're an airline, so we can start figuring out the data that our domain contains. This might be now a domain about, for example, flight management or pilot assignments or something like that. We need to figure out what do we need to know about. This is contextual metadata. We need to know about airlines, airports, aircrafts, flights and pilots, and who works where and in which country is an airport located and so on. So this is just mapping that understanding in a clear business language description of what the data really is about. Then we can use this higher level mapping of the domain here to decide that, okay, we want to build a data product that contains that part of it, and then provide the data product in a specific format. But the core idea of being able to describe what you have data about and how these things relate to each other is absolutely vital to understanding what the domains really contain. This brings extra special importance to the glossary itself. So the glossary must be made available to everyone. What do you mean by a customer has to be something that anyone can answer by looking at the glossary. There are words that mean they have different meanings in different domains. There are words that mean the same thing, but you're using different words for it in different domains and so on. And understanding that has to happen via a kind of shared business glossary, which links to all these domain-specific models. It's of course possible and it's usual that parts of the glossary are highly domain-specific, so no one else is using these terms because no one else cares about them, but it is still information that everyone needs to have access to. This kind of modeling work, when it starts from the business terminology and the glossary, this modeling work bridges the gap between business and IT. And the idea is that we need these different levels of data models for different levels of detail so that we can bridge the whole gap. The idea is that business glossary is purely kind of business-facing definition of what terms mean. The conceptual data model is what explains what information overall should exist. So we need to know that there are airlines and flights and so on. Once we get to that point, we start having a structure. And when we decide that we want to create a technical implementation, be it a data product or in fact anything, then we can create a logical data model that explains that, okay, from that mass of data that we have, this part we're interested in, and this is the structure we need to have it in. So the logical data model is, in effect, an implementation design for a specific use case, for a specific data product. And then we decide, okay, what technology we're going to be using, and with that technology come some limitations, maybe some optimization needs and so on and so forth. And applying those, we get the physical data model. And obviously then the physical data model just describes that the data within these technological components, this actual storage, it looks like this. But all of these levels are kind of interconnected, and we need all of them to be able to truly bridge this gap. So given that, now coming back to the data mesh principles, how does this link to the kind of philosophical idea of what data mesh is? If we consider domain-driven ownership of data, naturally this means that each domain has its own kind of reality. They live in their own little domain world. So they need to have the ability to model that reality, to show that to everyone else. This is what our reality looks like. This is what kind of data we have about it. So each domain must own its own data models. As they serve that data in data products, we need to have the capability to show on a lower level and a level of more detail how that data product is built. So we need lower level models, logical models, to be able to show people that this is our data product, this is what it actually contains. And this must be linked with the domain level understanding of what the data is about, so that we can convey the context of that data as well as its technical structure. So we use data models to communicate what the data product contains and how it is kind of interconnected with the rest of the information about the domain. In terms of self-serve capabilities, of course, all of this means that we need to be able to provide, first of all, access to all of these domains, all of these models to basically everyone, because people need to be able to see what these models look like and they need to be able to browse the glossary and so on. But it also means we need to have the competencies and the capabilities in technical and human sense inside the domains to actually do this work. And when it comes to governance, having the capability to do this kind of modeling and having the capability to collaborate and cooperate on this means that you need to be able to kind of find these problem areas, these overlaps between domains. You need to be able to discuss with other counterparts in different domains saying, hey, we have been modeling this like that. It seems that you are also using the same sorts of things. You are also talking about customers. Maybe we should kind of check how this modeling is done so that we are interoperable still. So we need to recognize where we have synonyms and stuff like that so that we can ensure everything is interoperable. Now, overall, if we consider now an example data mesh here, bunch of domains and data products, how this should kind of look like. How do you do this modeling work? First of all, what we suggest is that every single domain would always be documented with a conceptual data model, because the conceptual data model obviously it tells you what the structure is, what the domain is about. So it describes the domain, it gives the data products a business context. Then we have the logical data models, which explain how the data products actually work, what do they contain, and the logical data models are connected with the conceptual data model, and the data models on conceptual level contain business terms which are all coming from the business glossary. So the business glossary really links all the domains together. It is a repository of business terms. Having all these conceptual data models, having the business glossary connect all these domains also enables you to, if you like to, create a kind of higher level understanding, a mapping, an enterprise level model that really tells you how the domains are interconnected. So that's what modeling looks like in the mesh. In conclusion, of course, data mesh is a new and developing paradigm. It's early days. Yes, we know, but there are very good principles here, decentralization, domain focus, which require focus also on knowledge sharing and communication. So you need to be ensuring that those are in place. Data modeling is an excellent method for communicating and documenting that content and context of data, so it fits here very well. But you need to be able to use all different levels of data models, conceptual, logical, and physical, so that you can cover that whole gap there. Now, the modeling itself happens in the domain. That's very important because we want to have the domains kind of be able to do things on their own, but you have to allow visibility to everyone because the collaboration is important and you need to be able to ensure that the communication is actually understood properly. But as a final note, it's in fact so that even though we have been talking about data mesh here, all of these challenges about communication and understanding the content and the context, all of these are actually universal. So in fact, no matter what your approach is to data architecture, most of this is going to be very valid for you in any case. So all the frameworks you could possibly have will have to deal with these kinds of issues. It's just that in the mesh context, this is extremely, extremely important. And there you have it. That is how data modeling helps you with data mesh. If you want to try out Ellie and data modeling principles with your own data mesh initiatives or any other issues that you might have, go to Ellie.ai. You will find a free trial and contact details and all sorts of information that will hopefully help you forward. Thank you.